So today we're going to be exploring some of the simulation tools that we have available in Fusion. As most of the people watching this webinar might be familiar with, this is a Fusion design. This is a plane hanger, and we're going to perform some simulations to see if this hanger is going to fail under a certain weight that I can apply right here. Okay. So the first thing we need to know about the simulation in Fusion is that there is an entire environment dedicated to it, right? So when we switch from design to simulation, we're going to be prompted to select one of several design cases, all right? So there are many different tools that we can use right here on Fusion. They're basic vanilla out-of-box Fusion installation comes with regular static stress. So you can perform simple analysis. You can perform just for check for stresses, for deformations, those kind of things with static stress. But there are so many more types of simulations that you can perform here. You can perform model frequencies analysis in case you want to find the shapes, the frequencies for vibration on your model. You can do electronics cooling, that is, perform CFD analysis, add heat exchange analysis as well. You can perform thermal analysis. You can combine thermal and static stress to perform thermal stress analysis as well. You can perform structural buckling in case you want to check for components that are being evaluated under compression. You can check for nonlinear static analysis in case you have large deformations, in case you have nonlinear materials, basically everything that's nonlinear, basically. You can perform a dynamic event simulation, that is, perform an explicit dynamic simulation. You can perform quasi-static event simulation in case you want to describe non-linear material behavior in small periods of time. You can also perform shape optimization and injection molding, right? So ideally, I would go with one webinar with each one of those. The ideas that probably we'll do in the upcoming year. But for now, we're just going to explore the environment, the static stress, and we're going to introduce a couple concepts on other nonlinear analysis and in model frequencies as well, right? So let's create a static stress study. All right. If some of you guys there are already familiar with how you're supposed to perform a simulation in CAD in general, you might want to know that you need to specify your materials, you need to specify your constraints, you need to specify loads, you name it. All right. So the first thing we should check, well, besides the simplification of the part, would be the material we're going to be working on. All right. Fusion includes a very comprehensive list of materials, all with their proper information on the yield strength, with the yield modulus, you name it, right? Let's check. For example, I'm not sure which material I was using. I'm just going to overwrite material here. I'm going to specify this hanger is supposed to be a 1015. Let's take a look into this one. All right. So I can check the material properties right there on my library, right? So I got all the information from my material. I can even add new materials if I want to. There, Fusion has a very comprehensive set of materials, but you know how it goes. Usually, you want to adjust your material properly in some cases. So Fusion is going to let you do that. Okay. Now let's specify some constraints. I'm going to specify a fixed constraint in these holes right here and right there. All right, I'm going to specify a load. It's going to be applied right there on that face. I can apply this force in many different ways. I can even specify different types of loads. Of course, I can specify pressure, moment loads, bearing loads, remote forces on a single point. I can create connection elements if you fancy creating something a little more complex or more precise. You can add rigid elements. FEA guys there probably know what I mean. And I can specify the magnitude here, and I need to change to specify the units in any the force in any units that I don't want to. Of course, Fusion is very user friendly in that sense. Specify 10 pounds, so there's no need for you to. Oops, there we go, 10 pounds. There's no need for you to adjust the units to check what the results on your side are going to be. No need for that. Okay. Next thing we're going to do is we're going to specify our mesh. Of course, if we check the mesh settings, we have some control over how can I mesh my part. Specify a more refined mesh like this one. If I want to, I can also define very important properties on the mesh, such as the element order, want more precise calculations. So I'm going to select parabolic in this case. And now I'm going to generate my mesh. Right? Probably this is not the best mesh that we can produce for this type of model, of course, but you get the gist. We can refine this even more. We can do convergence analysis if we need to. And after this, well, this is the basics of structural analysis, right? So for the beginners out there, Fusion has a little check button, so it tells you if you need anything else. And here's where this comes funny. When you're gonna run a simulation in Fusion, what you're basically doing is taking that model, sending it over to the guys at Autodesk, and running the simulation on their premises. All right. So in order to do that, well, Autodesk might charge you in some other way, right? If you want to be able to just simulate basically anything, what you want to do is you want to activate or get the simulation extension, right? This gives you all the tools to do access to all the simulation types. But chances are that you might not want to get the entire Fusion simulation extension. For which case, whenever you're gonna send a simulation for solving, Fusion is gonna charge you some tokens. All right. So, for example, a static stress analysis is gonna charge you no tokens, right? But if you run model analysis, that's gonna cost you 3 tokens. If you run nonlinear material analysis, that's going to cost you other 3 tokens. If you run, I don't know, nonlinear with large deformations, coupled with thermal analysis, something like real complex, that's going to cost you 6 tokens, and so on. Okay, so no need for just paying extra for what you need. You can just pay on the go, depending on the types of simulations that you want to run. All right. In this case, if I send those to study, that's going to take a little time. So I'm just going to open this one with our results, all right? So in this first case, for example, the results I'm going to get something like this. I'm going to get a new node, it's going to show me the results, right? And I can evaluate for whatever this type of analysis allows me to. Okay, so in this case, I can check for the stress. In this case, I see that I have a very, very high stress concentration right there, 760. So I'm way over my elastic limit, sorry. I can check for deformations as well. I can set the units I want to look to that deformation in. And I can even check for safety factors. I usually don't recommend just checking for the safety factor. That's the first thing. Beginner just jumps up to do like, okay, it's less than 1, so it's not going to work. The idea is that you're doing some analysis, right? You're trying to understand what's going on with your model, and that means basically you reading into the results you're getting and taking a conclusion out of it. Okay, Fusion is going to help you a lot, but it's up to you as the designer to check what's going on right here. All right. In this case, for example, I have 2 problems. You see, first of all, I'm way over my elastic limit, right? And so anything above for this type of material, probably 280 megapascals, switch to KSI. So over 36 KSI, it's just too much, right? So the analysis the results I'm getting are not well at the right. So I need to do something about my design, right? The second thing I see right here that might want to make me think about doing a more complex design is this. You see that if we're thinking about how this hanger is going to work, I'm going to apply some force right here, but as soon as this portion of the hanger touches the support, I'm going to get contact, okay? And right now, there's no contact being applied. It's just like this is kind of floating around this band right here, all right? So what I'm going to do is I'm going to add some contact. I'm going to go back here, and I'm going to specify the type of contacts that I can create with Fusion, right? We're going to create manual contact. There's an automatic option, of course, but maybe as we explore what it's after, all right? So this is another, well, it works in the static analysis, but it's kind of non-linear behavior, right? Because what Fusion needs to understand it's how the mesh up here on this face is going to interact with the mesh on this face right here, right? So I'm going to specify a contact between 2 bodies. My first selection set is going to be this one right here. Second selection set is going to be somewhere around here, all right? So I can specify the type of contact that I want to. In this case, I'm going to pretend that 2 surfaces are welded, so I'm going to leave these ones as bonded, right? But if I want to, I can set them in any way that I want. For example, I can set them as a slider in case I don't want penetration between the 2, but I want to specify that they're supposed to be able to slide like 0 friction coefficient, right? I can specify separation in case I know that the surfaces, this would be like the most precise one. I know the surfaces are separated, but when I get, or when my material gets all the way down here, software is going to know that they're supposed to intersect. There's going to be penetration, and it needs to calculate for that. So in order to do that, it's not just going to calculate one solution, but it needs to run several solutions. It's an iterative process, right? It's going to calculate first for little loads, then another one, another one, another one. Like you're analyzing it through time, right? I'm analyzing at moment 0, 0.1, 0.2 seconds, 0.3, and so on, okay? So the more complex the type of contact is, well, the longer simulation will take, and the more expertise you need to know about the contact solution, right? But you get all those options right there. In this case, I'm going to leave it as bonded, For each one of those, I can specify the type of the information that I need for that contact. For example, for non-sliding, I can specify friction coefficients, I can specify stiffness factors, basically everything I need for my contact to work. All right. So in this case, I get some results as well with contact. Let's check our results. There we go. So now you see I don't have penetration and I have some high stress where I would expect, which is basically right there. Okay, so the solution makes a lot more sense. Now the stresses aren't that high, right? In the whoops, okay, sorry, there we go. In the sense that at least not something like real crazy that doesn't make any sense, like 100 KSIs or something like that. But we're over 36. So basically, what this is telling me is my hanger probably will have some plasticity over here. It's not going to work that well. All right. Another I can go even a little further down the road, and I could specify what's going to happen here or analyze what's going to happen here if I'm getting this type of deformations, right? If I check for displacements, you see that the displacement I'm getting right here, by the end, it's 13 millimeters, right? This is very high for the geometry that I have. And as some of you might know, our linear model for a material, it's gonna work, it's gonna be true as long as I have small deformations, right? If I have very large deformations, my material model is no longer accurate. Okay, so I need to specify for large deformations. So probably a good idea would be run a non-linear analysis with large deformations. So that's basically what I'm going to do here. I'm going to create a new case for this static stress case. I'm going to start a new study, and I'm going to specify a non-linear static stress analysis, right? It's going to let me select some material that has non-linear behavior. Okay, if I take a look at the materials that I have available right here in Fusion, you see that Fusion has a very complete non-linear material library as well. Okay, so ideally I would check on the materials right there. Okay. Even so, if the material you're not looking for, it's not here, you can always add new material on your model. All right. So in this case, I would select as standard structural nonlinear material, right? Just manage physical materials. There we go. There we go. These are our libraries, right? And in case you want to add materials, you can add them from here. You can specify all the basic advanced properties as well. Okay. So for example, for our nonlinear steel, you see I can set basic properties, the Young modulus, Poisson's ratio, shear modulus, yield strength, but I can also check on advanced properties. So this is the difference between one of these ones and a regular one. These ones include advanced properties on nonlinear behavior. And in case you need to specify more complex materials, you can add hyperelastic materials. You can specify temperature-dependent materials, you name it, right? And you can specify the data points for how the material behaves in a very easy to use graphic, correct? So that way we know that Fusion needs to adjust for a nonlinearity of that material in case I have large deformations. Other than that, I can't specify the same loads, can't specify the same constraints. So basically, I'm gonna add fixed constraint right there. I can add load right here. £10. There we go. Can specify contacts as well. First body, or hanger. Second body, the hanger itself. There we go. And then I can send those to solve, right? So when I have several studies, I can work on each one of them separately just by clicking on the radial button. That's it, okay? If I hit solve, I'm gonna get this window. It's basically telling me, okay, so what do you want to solve? I want to solve just a nonlinear, I want to solve the static, I want to solve both of them, right? And in the case that your extension is not active, this table is going to let you know, okay, so the static one is going to cost you 0, right? Static, regular, plain old vanilla static analysis is free for you with your purchase Fusion, but this nonlinear needs a certain amount of tokens, all right? In this case, already run these results, so I'm going to check those here. Linear view results. There we go. All right. So see that the deformations are pretty much what we expected, very similar to the ones on our linear analysis. But now we know for sure that the software did some adjustment for this type of analysis, right? Besides that, if I check on the stresses, I will be able to check on okay, sorry, there we go. I will be able to make sure that once I got past my tensile strength, that's my yield point, the analysis I'm getting, it's right, but it's considering plasticity, okay? So it's not just a matter of just telling you, okay, so it's above 36, so I'm done. This is not valid. I need to do something else. I can check. Please change something on the design or something like that. This is telling me basically, right, you're going to get this deformation, and chances are that at this point, you're going to get some plasticity, okay? But it's going to be just above your yield point, so you might find some deformation, some permanent deformation here, but your hanger, it's going to work. It's not going to break. It's going to deform a little bit. All right. Of course, we need to contrast. This would be like the first conclusion that you would get by analyzing the results. But of course, you need to do validation, verification as well. You need to run a mesh convergence analysis. You need to check that the solution you're getting it's converging to a single solution. Of course, you need to validate with well, probably not reality if you don't have the option to actually build this hanger and test it for yourself. But running with some prototype or some information on something physical in the real world to do validations, which is basically what you want to do every time you run a simulation analysis. All right. So in this case, for example, we might want to consider changing our design a little bit, right? So say I'm gonna make this support a little longer, right? So it moves all the way to the right. Chances are that, well, chances not, I'm certain that that's gonna cost me more because that's gonna be more material, but that might be something I might want to do. So I'm gonna change my sketch here. And I'm going to change this parameter to 250. It's a little too much. 200. Yeah. Sounds about right. So my design is updated with the change I just created. I did this on my original design. And the good thing about Fusion is everything is included in one single bundle. It's just one design. The simulation environment is going to read into this and it's going to update everything. All right, so no need for me to set up the analysis again. All I need to do is move to my simulation environment. And in this case, the only thing that I need to do is remesh, right? Because the only thing that changed for the analysis was the shape of the design, right? So I'm gonna get a little warning sign that's telling me, okay, your your mesh is out of date, right? So you need to update that. So all I need to do is generate the mesh again. Right, and boom, there we're ready to go. Right, so I can just run my pre-check, solve my solution, hit solve. Of course, just so you see what, how this looks, I'm gonna hit solve. Right, so what's going on right now is Fusion is reading the information that I have on my model and it's uploading that to the cloud and it's being solved in real time in Autodesk servers. That's basically what's going on here, all right? There we go. This is called as a job. So this is gonna appear in your job status window and this is gonna show the progress on your task. All right. Quick, I'm gonna send this one away. Quick, I'm just closing Inventor. That's taking a lot of memory for my computer right now. And in any way, yeah, I'm gonna open a new instance. Otherwise, it's gonna let me hang in while the simulation it's finishing, right? So just gonna open a new instance. All right, there we go. It's been a little slow lately. My computer need to check that. Anyway, let's see. I'm gonna check on my job status. There we go. So this is how this is gonna look. All right. So while the analysis is being run, I'm gonna get this status window. It's gonna let me know as soon as the job's finished. Up here, a little message gonna appear letting me know, okay, your study one static stress, it's basically finished. All right. So let me just pull up the results for the modified hanger. There we go. So this one's not right because this one had no contact. This one's the right. Okay, so now my point of high stress is it's not over here. Oh, there we go. That's the finished job. Okay, so the point of high stress is not right here. Now it's over here. The location where I'm gonna hold my hanger, right? And you see that the stress is it's lower than the yield strength of the material, right? So this is a better design, and I can make sure that my plane hanger it's gonna work properly. All right. Now there are many other types of simulations that I can run. For example, let's suppose I want to do a model analysis because I want to find the natural frequencies for vibration on my hanger, right? Actually, I think on the other one, I did change this to 250. Just so it looks right. Yeah. It will look like this. Yeah. I'm going to lie to you that the results for the other one were with the 200 millimeters measurement there, right? It's just like this one, right? So I was mentioning my simulation environment, for example, I might want to find the model frequencies for my hanger because I plan on placing repetitive loads in case I want to use those frequencies for a more complex analysis, for transient analysis, for response spectrum analysis. Probably, well, a plane hanger is not something that is subject to those kind of loads. But in any case, this is something that that you can specify here in Fusion. So I just want to show you how easy it is, right? On the model frequencies analysis, you can specify all the settings that you want for your analysis. In this case, we're going to use Langsdorff's method. You can specify the number of frequencies that you want to extract. So basically, the first 8 frequencies. And you can specify other settings for your mesh, for adaptive mesh, in case you want to refine your mesh in high stress areas, those kind of things. Okay. So for model analysis, all we need to do is specify the contact, right? So same as I did before. Set 1, set 2. Gonna specify constraints, otherwise the first 6 that I'm gonna get are basically 3 modes, but I want to find the response to my constraint hanger, right? Not a free hanger kind of blowing around space, right? And that's basically it. All I need to do is, almost that. I need to specify mesh settings. On advanced settings for my model analysis, I'm gonna switch this one to linear. Easier to find the eigenvalues of the matrix that way. And all I need to do is generate the mesh. That mesh looks like C, so I'm gonna refine that. There we go. That looks a little better. And now I can run and solve my model frequencies. All right. So same as before, I can check the analysis that I want to run. Hit solve. And when that's done, I can pull up my results right here. Okay, so for my model frequencies, I will get results like this one. I can specify the displacement, right? Oops. I can specify the total displacement, or in each one of the thermal directions, X, Y, Z. And here's the important part, the modes that I'm gonna get. All right, so I can see the mode response for the first frequency. That's 92 hertz. So that's gonna vibrate like this. It's gonna be two-way, stop, a little faster. There we go. Right, so horizontal movement for the first mode, vertical movement for the second mode at 168 hertz, and kind of wiggly, right, for the second mode. It's basically second mode, like a guitar string, if that makes sense, with the complete sinusoidal movement for the Y direction for mode 3, and so on, right? And that's just some of the stuff that you can do, right? And that's basically what I wanted to show you guys today. You know, if there are any questions. Oh. Right, so I don't see any questions for now. But as usual, you know, you can always ask questions via email for us. You can contact the marketing team if you want to set up a call, if you want to look a little bit deeper into these topics. We can offer not only the licenses, but we can offer training, custom training, basic training, you name it, right? So I hope this was entertaining, at least. And if you like this one, you might want to check on the next webinars that are going to come for Fusion. The next year, we're going to have Fusion Extensions webinar, basically for customization, automation on design on Fusion. All right? So thank you, everybody, for your attention, and I guess I'll see you around. Bye-bye.